So this is the second video on electrolysis, which will look specifically at examples of electrolysis, including aluminium extraction. If you haven't gone through the basics of electrolysis, please do go and watch that video first. Just to get started, 5 quick questions. Pause the video, have a go at the questions, and when you're ready, you can restart the video. Again, if you're struggling with these questions, I do recommend you go and watch the first video on electrolysis, which is the basics video. Okay, so the answer to question 1, an ionic compound is a compound made of a positive and negative ion, with the positive being a metal and negative being a non-metal. The process in which electrons are lost is oxidation. The loss of electrons is oxidation. The negative electrode is called the cathode. Ionic substances for electrolysis must be in 2 forms, and that's either in a molten state, or if it's soluble, we can dissolve it in water. And in covalent bonding, electrons are shared. We've mentioned this in the previous video. Electrolytes are ionic compounds, which means they have positive and negative ions in them. The ions have to be able to move in order for electrolysis to occur, so we need to have them in liquid form, either by heating them up to high temperatures, making them molten, or if they are soluble, we can dissolve them in water, and this will allow for electricity to be conducted through them. You also need to ensure when you're talking about electrolysis that you talk about the fact that electrolysis requires a direct current or DC current, and that you have a positive and negative terminal that you would attach the electrodes to on the battery. Just as a reminder, the positive electrode is called the anode and the negative electrode is called the cathode, and the positive anode will have negative non-metal ions move towards it, whereas the positive metal ions will move towards the cathode. In electrolysis, we always talk about what happens at the anode and what happens at the cathode separately. And again, I would suggest that you put down those as subheadings in any answer you do, in particularly long answer questions. But at the anode, what happens is that the negative ion moves to the positive anode. When it touches the positive anode, electrons are stripped off it. And remember, the loss of electrons is oxidation, so the negative ion gets oxidized, and those electrons are sent off around the circuit to the cathode. When we get to the cathode, the negative ion touches the anode, the electrons are removed, the electrons travel all the way to the cathode, and the positive ion, when it touches the cathode, it accepts those electrons against those electrons, so the positive ion is reduced. And again, this is covered in more detail in the previous video, but you need to remember using any method you want, but oil rig and Leo the Lion are 2 examples of oxidation is the loss of electrons, or loss of electrons is oxidation, and reduction is the gain of electrons, or the gain of electrons is reduction. It doesn't matter which method you move, as long as you remember that reduction and oxidation. Now, when it comes to extracting metals, you do need to know the reactivity series, and you do need to know where carbon and hydrogen are in the reactivity series. If you haven't memorized this up to now, I strongly recommend that you pause the video, go through the first letter of each of the elements, and you can learn them off as a mnemonic or whatever version you want to learn, but you do need to know the entire reactivity series for your chemistry exam. A good little tip though is that when it comes to hydrogen, anything that's used to make jewelry, so copper, silver and gold, will be less reactive than hydrogen. Everything else will be more reactive. So that is a quick and easy way just to remember in terms of hydrogen for electrolysis. Anything that makes jewelry, so copper, silver or gold, will be less reactive than hydrogen, and that's important when you're working out what's happened in electrolysis. As always, quick quiz, 5 questions. Pause the video now, and when you're ready, restart and we'll have a look at your answers. So question number 1 is aluminium more reactive or less reactive than copper? Well, aluminium is not one of the metals that we said about making jewelry, so it's going to be more reactive. Why is electrolysis so expensive? Well, there's 2 main reasons for it. Obviously, the process of electrolysis is always going to involve the use of electricity, and electricity has become very, very expensive. But it's also quite expensive to actually melt the compounds down. So if you need something in molten form, it takes a lot of heat energy to make that down, and as a consequence, you'll spend an awful lot of money doing that. The positive electrode is the anode. The process of gaining electrons is reduction, because gain of electrons is reduction. And when we have an ionic compound, it is made up of positive and negatively charged ions, with the positive being a metal and the negative being a non-metal. So now we're going to go into look at the extraction and process of getting aluminium metal out of aluminium ore. Aluminium ore is what we dig out of the ground, and it's referred to as bauxite. So we need to get bauxite out of the ground, and it's purified and cleaned up until we get what's called aluminium oxide, and then we put the aluminium oxide into the process of aluminium extraction by electrolysis. There's a couple of other things we need. We also use a chemical called chloride. I'll mention in a second what that's for. We also have to use carbon anodes, and there's a very specific reason why we use carbon anodes as the positive electrode. So now we're going to look at the extraction of aluminium from the aluminium oxide. You can see in the diagram that we have an anode and a cathode, just like we would have in any electrolysis, but it's just in a slightly different arrangement. It also specifically says that we use carbon as the electrodes, and you can see that as we go through, we start off by getting the aluminium down into a liquid form, and the aluminium oxide is melted down into a molten state because it's insoluble. Unfortunately, aluminium oxide is a very high melting point, which means that it's a very expensive process. So we add the chloride in because chloride lowers the melting point of aluminium oxide, and it makes it a little cheaper for melting down the aluminium oxide into its molten form. We also have carbon electrodes. Specifically, we use graphite, and I'll mention why we get that in a second. At the cathode, remember the cathode is the negative electrode. As it's the negative electrode, the positive ion will go to it. In this case, the positive ion, always being the metal, is aluminium 3+. And what will happen is 3 electrons will add themselves onto that aluminium 3+ ion to make the atom of aluminium. Now that aluminium, because it's still molten form, will literally sink to the bottom, and there'll be a big layer at the bottom that can be removed. At the anode, we have a release of oxygen gas. And when we have oxygen gas, we are taking the oxygen ions, we are taking the electrons away from it, and as a consequence, we are oxidizing the oxygen, because the loss of electrons is oxidization. However, oxygen is highly flammable, so we don't really want big clouds of oxygen going around any factory, particularly when there's large amounts of heat and fire and all sorts. So what we do is the oxygen will actually react with the carbon in the anode to form carbon dioxide. So carbon dioxide gas is given off. The problem with that is that the carbon in the anode then gets used up, and after a while the carbon anode needs to be replaced, and again that brings more cost into the extraction of aluminium. So that's your overall process. We start with making the aluminium oxide molten by melting it down. We make sure that we add in the chloride to bring down the melting point to make it a little less expensive to make it molten. We have carbon electrodes. At the cathode, the aluminium ion is reduced to form aluminium. The molten aluminium sinks to the bottom and then gets removed. At the anode, we have oxygen being oxidized because it is losing electrons. So the oxide ions are losing electrons to form oxygen gas. And we have 2 ions because we want to form O2 molecules. As a consequence, we end up with 4 electrons, 2 from each of the oxide ions. But that oxygen will react with the carbon on the anode, and as a consequence we get carbon dioxide. But for that reason we have to go back and replace that carbon anode on a regular basis, because the carbon is being used up and lost as carbon dioxide, which again increases the cost of extracting aluminium. We got 5 questions. Pause the video. When you're ready you can restart the video. So question 1, what is added to aluminium oxide and why is it added? Well, what we add in is the cryolite, and what that does is reduce the melting point of aluminium oxide, meaning it's a little cheaper to get the aluminium oxide into molten form. In question 2, aluminium extraction, what happens at the cathode? Well, at the cathode, the positive ion, which in this case is aluminium, is gaining electrons. So the gain of electrons is reduction. So the aluminium ion is reduced to form aluminium. And again, for those in the higher, you should be saying that we actually gain 3 electrons to be able to form the little equation. What metals are less reactive than hydrogen? Well, that comes down to us making jewelry. So it's our copper, our silver, and our gold. What gas is released at the anode? Well, in this particular case, we have oxygen gas produced in the process, but it then reacts with the carbon at the anode, releasing carbon dioxide gas. And why must the anode be replaced? Because the carbon anode is used up when it reacts with the oxygen to form that carbon dioxide. So now we're going to look at electrolysis when we are dealing with water-soluble substances. So the 2 ways that we can get things ready into a liquid state for electrolysis, either by heating them up till they're molten or by dissolving them in water. When we bring water in, we then bring in 2 new ions. So up until this point, with every example we've had, we've only had a positive and a negative. When you put water molecules in there, we now end up with 2 positive and 2 negative, because when you do electrolysis and you have a soluble substance, the water molecules are separated up into a positive hydrogen ion and into a negative hydroxide ion. So as well as our metal and non-metal, we will have these H pluses and OH minus ions. So it doesn't matter what chemical they give you in the question. As long as you learn a set of rules, you'll always be able to work out what's going on at the anode and cathode. And just like I've said previously, I would always talk about the anode with one subheading and talk about what happens there, and then do the cathode and what happens at a different subheading. You also need to make sure that you have gone through and you have learned off your reactivity series, because you will need to know the reactivity series in terms of more or less reactive than hydrogen. And again, the rule is that if it's used to make jewelry, copper, silver, or gold, it'll be less reactive than the hydrogen. So at the anode, the rule is that if you have chlorine, bromine, or iodine, which are in group 7 of the periodic table of the halides, then they are the gas that gets released. So if we have a halide, chlorine, bromine, or iodine, inside our solution, that is the gas that will get released. If, however, there is no halide present, so no chlorine, no bromine, no iodine, then oxygen gas will be given off. So you'll always get a gas, you'll always get bubbles at the anode, but it depends if it's chlorine, bromine, iodine, or oxygen, depending on what chemical you are using. At the cathode, we have that rule about hydrogen. Remember, we said on the reactivity series, less reactive than hydrogen is our jewelry, which is our copper, our silver, and our gold. So if the metal is more reactive than hydrogen, then we will form hydrogen gas at the cathode. If, however, it is copper or silver or gold, it is less reactive than hydrogen, and you'll actually get a layer of that particular metal appear around the cathode. So the first thing I do in any question is I'd look at the chemical, I'd look at the chemical formula, and I would identify what the ions are going to be. So in copper sulphate, it says the word aqueous. That means it is dissolved in water. So we break the water molecule up into the H plus ion and the OH minus ion. And then we get our copper sulphate, and the Cu copper will be the positive ion, and the SO4 will make a negative ion. As a consequence, at the anode, we will find the two negative ions, OH- and SO4 2-, whereas at the cathode, we'll find the two positive ions, H+ and Cu2+. So we're going to start with the anode, and using our rules from before, copper sulphate does not have chlorine, bromine, or iodine in it, so it has to release oxygen gas at the anode. Remember, oxygen gas is O2, which means that we need two oxygens, and the oxygen actually comes from the hydroxide. So we need 4 hydroxides, and we break the 4 hydroxides up to form an O2 molecule and 2 H2O molecules, leaving 4 electrons to go from the anode through the circuit all the way over to the cathode, and they can be donated to the positive ions. At the cathode, we use our hydrogen rule. So we're looking for the metals that are less reactive than hydrogen, which is copper, gold, and silver. And in this question, we do indeed have copper. Because the copper is less reactive than hydrogen, we actually form a layer of copper around the cathode. It literally coats the cathode. And again, for the higher people, we need to talk about that in terms of electrons. Well, copper is a 2+ ion, which means it has to gain 2 electrons to become an atom. And if you replace that cathode, instead of just the rod that's in the diagram, you can replace that with anything you basically want, and you will have exactly the same process happen, but they will coat that in a layer of copper. If it was gold or silver in the question and the chemical you started with, a layer of gold or layer of silver would be formed as well. Time for another quick quiz. Pause the video, answer the questions, restart the video when you're ready. So pause now. So what ion moves to the anode when the copper sulphate is used? Well, the anode is positive, so it will be the new negative ions, and the two negative ions are the hydroxide, the OH-, and the sulfate ion, which is also a negative ion. Why does copper form a 2+ ion? Well, it forms a 2+ ion because it has 2 electrons at its outer shell, and it will lose those 2 electrons, hence 2+. Why is oxygen gas and water formed at the anode? Because we don't have any halides. If we had chlorine, bromine, or iodine involved, then we would not form that oxygen gas. What is the equation for the anode that forms the oxygen and water? Well, we need our 4 OH-, which is then converted into an O2 molecule, 2 water molecules, and leaves us with 4 electrons. And then why is the cathode coated with copper? Because copper is less reactive than hydrogen. Remember, if it's a jewelry metal, then it's going to be less reactive than hydrogen, so that's our copper or gold or silver, and we will get a layer of that particular metal wrapped around whatever's on the cathode. And it doesn't matter if it's a particular rod or if it's a piece of jewelry or if it's a key, you will end up with that layer of metal. Let's have a look at another example. This time we're going to do sodium chloride. Again, just like before, we're going to identify the ions. So we split our water molecule up into our H+ and OH-, and we have our sodium, which is our metal, so it forms a positive ion. It's in group 1, hence it's only a +1 ion, and chlorine is a -1 because it's in group 7. In terms of the anode and cathode, the 2 negative ions go to the anode and the 2 positive to the cathode. We're using exactly the same rules as before, so we look for chlorine, bromine, or iodine, and this time we are involved with a chloride ion, so we will have chlorine involved. As a consequence, at the anode, we will actually form chlorine gas because we will get that Cl2. Because Cl2 needs 2 chlorines, we need 2 chlorine ions, the 2Cl-, and they will then have their electrons removed, and the loss of electrons is oxidation. So the chlorine ions get oxidized and they will form 2 chlorine atoms, which will give us our gas, chlorine gas, which is green, and 2 electrons left over, and those electrons will move around the circuit. The hydroxide just stays in solution. At the cathode, we go and use our hydrogen rule with our reactivity series. So we look at the metal, it is sodium. It is not one of the three jewelry ones, therefore it is more reactive than hydrogen. Because it is more reactive, we will actually form hydrogen gas. And again, hydrogen gas is diatomic, so it's H2, which means we need two hydrogen ions. Each of those ions needs one electron each, so we need 2 electrons in total to form the H2 molecule, and the sodium just stays in the solution. Time once again to test your knowledge with a quick quiz. So pause the video now, go through your answers, and then restart when you're ready. So why are oxygen and water not formed at the anode? Well, they're not formed because the chloride ion is there, and the chloride ion means that we will form chlorine gas rather than the oxygen gas. Why is hydrogen formed at the cathode? Well, it's because the sodium is more reactive on hydrogen. It's further up the reactivity series. It's not copper, silver, or gold, which are less reactive than hydrogen. At the cathode, we have the hydrogen ions getting reduced. For people on higher, you need to talk about that in terms of the actual equations with 2 H plus ions and 2 electrons, one for each of the ions, forming a H2 molecule. At the anode, the chlorines are oxidized because the chlorines are having their electrons removed, and we need 2 chlorines so that we form the Cl2 gas. And why is hydrogen gas produced? Because the sodium is less reactive than the hydrogen.